All right, load balancing. Um, Not exactly the sexiest term in the tech world, but it's the unsung hero behind every smoothly running enterprise application.
Yeah, think about it. Everything relies on applications these days.
Right.
Closing deals, managing projects, everything.
Yeah.
What happens if those applications slow down, glitch out? Even worse, completely offline.
Oh, chaos.
Yeah,
Productivity plummets.
absolutely.
Deadlines missed, employees frustrated. It's like, the nightmare scenario.
It is, and that's exactly where load balancing comes in. It's like a traffic control system
Hmm.
for your data, making sure everything flows smoothly, efficiently between your users and your applications, even when things get really busy.
Okay, so like a digital air traffic controller, making sure all the data planes land safely and on time. But we're not just talking about websites, right? This is for like enterprise applications, the critical systems that businesses depend on every single day.
Absolutely. Your CRM systems, ERP platforms, virtualized environments, all of the essential applications that keep the business running. And load balancing plays a crucial role in ensuring their performance, reliability, and scalability.
Okay, so in simple terms, what is load balancing doing for these enterprise applications?
So imagine you have a team of servers handling all the requests coming in from users. Without load balancing, all those requests might end up piled onto one server, which could cause it to overload and potentially crash. Load balancing intelligently distributes those requests across multiple servers, ensuring no single server gets overwhelmed.
So it's like having a team of chefs in a busy restaurant kitchen. The load balancer is the head chef, making sure all the orders are distributed evenly, no one gets backed up, and every dish goes out on time.
That's a great analogy. And just like in the kitchen, the goal is to keep everything running smoothly, efficiently, and without any, bottlenecks or delays.
Okay, so I think I'm starting to get the basic idea. It's all about preventing those dreaded server meltdowns and making sure that applications can handle even the busiest periods. But I'm guessing it's more to it than just distributing requests evenly.
Right. You're absolutely right. There are different ways to achieve load balancing, and the choice of method can have a big impact on performance, reliability, and cost.
So it's not one size fits all. There are different types of load balancers, each suited for different needs and environments.
Exactly. And for enterprise applications, understanding these nuances is crucial. Let's start with the classic workhorse, the hardware load balancers. These are powerful, dedicated devices designed to handle high-traffic, demanding environments. They sit in front of your servers, acting as that intelligent traffic cop we talked about.
So if I'm picturing this right, it's like a physical piece of equipment, a dedicated appliance specifically for managing the flow of traffic to my servers.
Precisely. They offer incredible performance and reliability, but they can be expensive and less flexible than other options. Now, in today's world, where many enterprises are moving towards more agile and cloud-based architectures, software load balancers have become increasingly popular.
Software load balancer. So instead of a separate piece of hardware, this is software that runs on existing servers or virtual machines.
Exactly. They offer great flexibility and can be more cost-effective, especially for businesses with dynamic workloads or those embracing cloud-native approaches.
Okay, so we've got the robust hardware option and the more adaptable software solution. Are those the main contenders? Or are there other flavors of load balancing out there?
Well, as more businesses move towards cloud computing, cloud-based load balancing has become a popular choice. Essentially, your cloud provider manages the load balancing service for you.
So it's like outsourcing your traffic management to the experts, basically. That sounds pretty convenient, but I imagine there might be some trade-offs.
There are. While cloud-based load balancing is very scalable and often billed on a pay-as-you-go basis, it does tie you to that particular provider's ecosystem. So you're handing over a crucial part of your infrastructure to a third party.
Interesting. So we've got hardware, software, and cloud-based options. Is that the full spectrum of load balancing choices? Or are there even more specialized approaches?
There are. Think about companies with a global presence. They might use global load balancing to distribute traffic across multiple data centers worldwide, ensuring a smooth experience for users regardless of location. And then there's application load balancing, which works at a more granular level, directing traffic to specific services within an application.
Okay, so it's getting even more sophisticated. Different types of load balancing for different layers of the infrastructure. But before we get too deep into the weeds here, let's zoom back in and talk about how these load balancers actually decide where to send all this traffic. And I remember you mentioning something about algorithms.
Ah, yes, the brains of the operation. These algorithms are the decision-making logic behind load balancing. They determine which server gets each incoming request based on a set of rules.
Right, spill the beans. How do these algorithms work? Do they have names? Are they super complex? Give me the inside scoop.
Well, some are simpler than others. Take round robin, for example. Imagine you're dealing cards around a table, one to each player in turn. That's essentially how round robin works. It distributes requests to each server in a fixed, predictable order.
Okay, I can picture that. Simple and straightforward. But doesn't that mean that some servers might get overloaded if they happen to get more demanding requests in a row?
You're absolutely right, which is why there are more sophisticated algorithms that take into account things like server load, response times, and even the type of requests coming in. One popular algorithm is least connections.
Least connections. So this one tries to be more efficient, sending requests to the servers that are currently handling the fewest connections.
Exactly. It's like a smart maitre d' who can see which tables are about to fill up and directs customers to the ones with more space. It's a great way to ensure that busy servers don't get bogged down while others sit idle.
That makes sense. It's all about dynamically adapting to the real-time traffic conditions. So we've got round robin for basic distribution and least connections for a more intelligent approach.
Are there other popular algorithms we should know about?
Absolutely. There's IP hash, which uses the client's IP address to consistently direct their request to the same server. This is useful for applications that require session persistence, where it's important for a user to interact with the same server throughout their session.
So if I'm working on a complex task in an application, IP hash makes sure I don't get bounced around to different servers and lose my progress.
Exactly, and those are just a few examples. There are many more sophisticated algorithms out there, each with its own strengths and use cases, designed to optimize performance, reliability, and resource utilization. This is fascinating. It's like there's a whole world of intelligent decision-making happening behind the scenes, all geared towards keeping those enterprise applications running smoothly.
It's a testament to the power of these systems. But the real question is, why should you care about all these details? What does it all mean for businesses trying to make the right choices for their applications and their bottom line?
That's a great question. We've covered a lot of ground here, from basic concepts to different types of load balancers and those clever algorithms. It's a lot to digest. But before we get into the why, let's do a quick recap of the what.
Sounds like a plan. Let's make sure we're all on the same page before we dive deeper into the strategic implications of load balancing for your business. Okay, so recap. We talked about how load balancing is, well, it's essential for keeping those enterprise applications running smoothly, distributing traffic across multiple servers to prevent bottlenecks and crashes. We also, we touched on the three main flavors: hardware, software, and cloud-based load balancers.
Right, and we even peek behind the curtain uh, at those clever algorithms,
Yeah.
like round robin, least connections, and IP hash, that decide which server gets each request. But now, I'm really curious about the real-world implications for businesses. I mean, how do these different types of load balancers actually play out in, an enterprise setting?
That's a great question, and it's where things get really interesting. Let's dive into the specifics, starting with those heavy-duty hardware load balancers.
Okay, those were the ones you described as the workhorses, right?
Mm.
Built for handling massive amounts of traffic, demanding workloads.
Exactly. Think of them as the Fort Knox of load balancers. Incredibly robust, secure, and designed for mission-critical applications,
Mhm.
where even a few seconds of downtime could be catastrophic for the business.
So in what kind of scenarios would an enterprise actually need this level of load balancing firepower?
Imagine you're a large financial institution processing millions of transactions every day, or a healthcare provider managing sensitive patient data, or a major e-commerce platform handling a surge in traffic during a holiday sale. These are the kinds of situations where hardware load balancers really shine.
Okay, I'm starting to see the picture. High stakes, high volume, zero tolerance for downtime. But you also mentioned they can be expensive and less flexible. Can you elaborate on that a bit?
Well, first off, they're dedicated appliances, meaning they require their own physical hardware and often come with a hefty price tag. And because they're specialized pieces of equipment, they might not be as easy to scale up or down as your needs change.
So you really need to be sure that a hardware load balancer is the right fit before making that kind of investment. It's not a decision to take lightly.
Exactly. But there's a reason why they're still the gold standard for certain use cases. They offer unmatched performance, reliability, and security. They're built to withstand the most demanding conditions and keep those critical applications running no matter what.
Sounds like the equivalent of having a dedicated team of security guards and traffic controllers, working around the clock to protect your data and keep everything flowing smoothly.
That's a great analogy. Now let's shift gears and talk about software load balancers.
Okay, these are the ones you described as more agile and cost-effective. They run on existing servers or virtual machines, right?
Exactly. And that's a major advantage for enterprises that are embracing cloud computing, virtualization, or more dynamic development practices. They offer a level of flexibility that hardware load balancers simply can't match.
So it's like having a team of traffic controllers who can adapt to different traffic patterns and road conditions on the fly, rather than being stuck in a fixed location.
That's a great way to put it. Software load balancers can be easily deployed and configured in various environments, making them a great fit for businesses that are constantly evolving and adapting their IT infrastructure.
But do they compromise on performance or features compared to those powerhouse hardware solutions?
Not necessarily. While they might not be able to handle the same sheer volume of traffic as a top-of-the-line hardware load balancer, they can still deliver excellent performance, especially for applications with more moderate traffic demands or those designed with, scalability in mind.
And from a cost perspective, they sound like a much more appealing option for many businesses, especially those that might not have the budget for dedicated hardware appliances.
Absolutely. Software load balancers can be a very cost-effective solution, especially when you consider the flexibility they offer. And they can be a great way for businesses to dip their toes into the world of load balancing without making a huge upfront investment.
Okay, so software load balancers sound like a compelling choice for enterprises that value agility, scalability, and cost effectiveness. But what about businesses that are fully committed to the cloud? Is there a load balancing option that caters specifically to those needs?
You bet. Cloud-based load balancing is essentially a managed service provided by your cloud provider. They handle all the infrastructure, the software updates, the security, everything.
So it's like having your traffic control team operating out of a virtual control tower in the cloud. Sounds pretty hands-off and convenient.
It definitely can be. And it often comes with a very granular pricing models where you only pay for what you use. This can be a huge advantage for businesses with, fluctuating workloads or those experiencing rapid growth.
But there's that vendor lock-in issue we talked about earlier. Once you choose a cloud-based load balancing service, you're pretty much tied to that provider's ecosystem.
That's a valid concern. You need to carefully consider your long-term cloud strategy before going all in on a cloud-based load balancing service. But if you're already heavily invested in a particular cloud platform, it can be a very seamless and efficient option.
Okay, so we've got hardware load balancers for those mission-critical high-traffic scenarios, software load balancers for agility and cost effectiveness, and cloud-based solutions for businesses embracing the cloud. It's like a choose-your-own-adventure for load balancing. But I remember you mentioning some other types like global and application load balancing. Can you shed some light on those?
Absolutely. Those are more specialized approaches that address specific needs, within an enterprise architecture. Let's start with global load balancing.
Okay, this one sounds intriguing. What's the global perspective all about?
Imagine you're a multinational company with data centers and users spread across the globe. You want to make sure that your applications are always accessible and responsive no matter where your users are located. That's where global load balancing comes in.
So it's like having a network of traffic control towers, each responsible for directing traffic in a specific region of the world, all working together to ensure a smooth and efficient flow of data.
That's a great way to visualize it. Global load balancing can distribute traffic across multiple data centers, taking into account factors like server load, network latency, and even the user's geographic location.
So if I'm a user in Europe trying to access an application hosted in the US, global load balancing might direct my request to a data center in Europe. That's closer to me, resulting in a faster, more responsive experience.
Exactly. It's all about optimizing performance and minimizing latency for users around the world. And for businesses with a global footprint, it's essential for providing a consistent and seamless experience regardless of location.
Okay, that makes sense. Global reach, global load balancing. What about application load balancing? What makes it different?
Application load balancing takes a more granular approach. Working at the application level rather than the server level, it can distribute traffic to different instances of an application, or even to specific services within an application.
So it's like having a traffic director.
Mhm.
inside the application itself, making sure that all the different components are working together harmoniously.
That's a great analogy. Imagine you have a complex application with multiple microservices, each responsible for a specific function. Application load balancing can intelligently route requests to the appropriate microservice, ensuring optimal performance and resource utilization.
Okay, so it's like having a specialized team of traffic controllers for each department within your application,
Yeah.
making sure that everything runs smoothly and efficiently. I'm starting to see how all these different layers of load balancing work together to create a robust and resilient infrastructure for enterprise applications.
Exactly. And that's the key takeaway here. Load balancing isn't just a single technology. It's a comprehensive approach to managing traffic and optimizing performance across your entire application landscape.
It's like having a multi-layered traffic management system with different teams of experts working at different levels to ensure a smooth and efficient flow of data. But with all these options available, how does an enterprise actually go about choosing the right load balancing solution for their specific needs? It sounds like a pretty daunting task.
It can be, but it doesn't have to be overwhelming. There are some key factors to consider that can help guide your decision-making process.
Okay, give us the inside scoop. What are the key questions businesses should be asking themselves when navigating this load balancing landscape?
Let's start with the basics. What are your traffic patterns and workload demands? Are you dealing with massive amounts of traffic, or are your needs more modest? Do you experience predictable traffic spikes, or are your workloads more consistent?
Okay, so it's like figuring out how much weight you need to haul
Hmm.
or how many passengers you need to accommodate before choosing a vehicle.
Exactly. If you're dealing with mission-critical applications that demand, the absolute highest levels of performance and reliability, and you have the budget to support it, then a hardware load balancer might be the way to go. But if your traffic is more moderate and your budget is tighter, a software-based solution could be a more practical choice.
And what about businesses that are all in on the cloud? It sounds like a cloud-based load balancing service might be the most natural fit for them.
It often is, but you need to carefully consider the implications of vendor lock-in and make sure that the provider's service offerings align with your specific needs and your overall cloud strategy.
This is really helpful. It's like having a roadmap to navigate the load balancing jungle. But there's still one piece of the puzzle I'm curious about. Those clever algorithms we talked about earlier. How do you choose the right one? Does it even matter?
It absolutely matters. Choosing the right algorithm can have a significant impact on the performance, efficiency, and even the user experience of your applications.
Okay, so spill the beans. What are the secrets to choosing the right algorithm for the job?
Well, let's delve into those fascinating algorithms and explore how they can be strategically deployed to optimize your load balancing strategy.
Okay, so we've explored the different types of load balancers from those robust hardware solutions to the agile software options and the convenient cloud-based services. We even touched on those specialized approaches like global and application load balancing. But now it's time to get into the nitty-gritty of those clever algorithms that actually decide where to send each incoming request.
You're right. Those algorithms are the brains of the operation. They're the decision-making logic that determines which server gets the honor of handling each request. Choosing the right algorithm can make a huge difference in how efficiently and reliably your applications perform.
Okay, I'm all ears. Let's break down those algorithms. Remind me about some of the key players and why they matter.
Well, we have the classic round robin, which we discussed earlier. It's like dealing cards. Each server gets a request in a fixed, predictable order. It's simple, straightforward, and works well for, applications with fairly even workloads. And where session persistence isn't critical.
Right, round robin, the fair and square approach. But you also mentioned that it can be a bit too simplistic for some scenarios, especially if you have servers with varying capabilities or if session persistence is important.
Exactly. That's where algorithms like least connections come in. This one takes a more dynamic approach, favoring servers with fewer active connections. It's like a smart traffic cop directing cars away from congested lanes and keeping everything flowing smoothly.
So if I'm a user trying to access an application,
Hmm.
during a busy period, least connections increases the chances that my request will be sent to a server that's not already overloaded, resulting in a faster, more responsive experience.
Precisely. Least connections is a great choice for applications with dynamic workloads. where traffic patterns can fluctuate unpredictably. It helps ensure that no single server gets bogged down and that, resources are used efficiently.
And then there was that IP hash algorithm,
Yeah.
which sounded particularly interesting for applications where users need to interact with the same server throughout their session.
Right. IP hash is all about consistency. It uses the client's IP address to consistently route their requests to the same server. This is essential for applications that rely on session data, like e-commerce platforms where users need to maintain their shopping carts,
Mhm.
or online banking systems where security and data integrity are paramount.
So if I'm in the middle of a complex transaction, IP hash ensures that I don't get bounced around to different servers
Hmm.
and potentially lose my progress.
Or compromise sensitive data.
Exactly. It provides that sticky session experience that's crucial for certain types of applications.
This is all starting to make sense. It's like having different tools in your load balancing toolbox, each designed for a specific purpose. But with all these algorithms to choose from, how does an enterprise know which one is the right fit for their applications? That's where careful consideration and collaboration with your IT team or load balancing provider come into play. You need to analyze your application's, specific needs, traffic patterns, and performance requirements.
So it's not a one-size-fits-all approach. It's about tailoring the load balancing strategy to the unique demands
Yeah,
of each application.
precisely. For example, if you have a web application with, lots of short-lived stateless requests, round robin might be a perfectly adequate choice. But if you have an application with long-lived sessions where maintaining that sticky session is crucial, then IP hash would be a better fit.
And if you have an application with highly dynamic workloads where traffic patterns can change rapidly, then least connections might be the way to go.
Exactly, and those are just the basic algorithms. There are even more sophisticated options that take into account, factors like server response times, geographic location, and even the type of requests coming in.
It's amazing how much nuance and complexity there is to this seemingly simple concept of load balancing. It's like there's a whole science behind it.
It really is, and the more you understand, these intricacies, the better equipped you'll be to make strategic decisions that benefit your business.
This has been an incredibly insightful deep dive into the world of load balancing. I feel like I've gained a whole new appreciation for this often overlooked but critical technology.
It's been a pleasure sharing these insights with you. I hope our listeners feel empowered to ask the right questions, explore the different options, and choose the load balancing solution that best aligns with their specific needs and their overall IT strategy.
Absolutely. To our listeners, don't be afraid to get into the details. Talk to your IT team or your load balancing provider. Explore those algorithms. And remember, load balancing isn't just about preventing crashes. It's about optimizing performance, enhancing reliability, and ensuring that your applications can handle whatever challenges come their way.
It's about providing a seamless and efficient experience
Yeah.
for your users, which can ultimately translate into increased productivity, higher customer satisfaction, and a stronger bottom line.
Well said. And on that note, we'll wrap up this deep dive into the world of load balancing. Thanks for joining us. And until next time, may your applications run smoothly, your data flow freely, and your business thrive.